Hello, today we are doing Chapter 5, Section 4. Our essential question is, can a system of linear equations have no solution or infinitely many solutions? So right now we're going to be talking about kind of the special cases. What we've done up to this point is everything has one solution. And if we were to graph them, what we've done with graphing or with substitution or elimination, one solution, and the lines would intersect at one spot. If you graph them and the lines are parallel, it would be no solution. And if you graph them and the lines lie upon each other, they're the same line, then it's infinitely many solutions. So let's go ahead and we're going to solve. And I'm going to show you actually two methods. We're going to probably use substitution and graphing. So let's start off with the graphing. So method 1, you graph both lines. The y-intercept here is 1. You go, and the slope is 2, up 2 over 1. Here my y-intercept is -5. I'm going to go up 2 over 1. And if you were to graph those, they are parallel. They do have the same slope. So they are not going to intersect. So that would be no solution. Sorry, I just hit pause there for a second. I needed to let a dog inside, if you were curious. So, because they have the same slope and different y-intercepts, the lines are parallel. And you should remember that from the last chapter, same slopes, parallel. Because they don't intersect, no solution. Let's go ahead and do this by substitution. I'm going to substitute, really kind of just set them equal to each other. 2x minus y. And put that in for that y right there, or 2x minus 5, put that in for that y. So you're really going to be getting them equal to each other. So 2x minus 5 equals 2x plus 1. Subtract 2x from both sides and you get -5 equals 1. Well, everybody knows that that's not a true statement. -5 does not equal 1. So because we ended up with a false statement, we can say no solution. Let's go ahead and do another example. Here I have 2x plus y equals 3 and -4x plus 2y equals 6. So let's do method 1. Let's graph them. Again, you could probably go ahead and graph this on Desmos if you wanted to, and we talked about that in one of our earlier lessons, desmos.com. You can just type it in, the equation, and it's very easy to use. Otherwise, I probably would have put these in slope-intercept form. Subtract or add 2x to both sides. On this top one here, add 4x, then divide by 2. And if you notice, one line is lying on top of another line. They are actually the same line because they're on top of each other. Whoops. Sorry about that. So, because your lines are lying on top of each other, they have the same y-intercept and the same slope. That is infinitely many solutions. In our next method, method 2, let's solve this by elimination. So I'm going to multiply equation 1 by -2. Let's go back up here and revisit that. Here I have a positive 2y. The opposite of that is -2y. So I multiply by -2, and I get 4x minus 2y equals -6. And just rewrite that second equation down all over again. -4x plus 2y equals 6. Add those guys together. My y's cancel. My x's cancel. and my 6's cancel. So you end up with 0 equals 0. Well, that is true. 0 does equal 0. That's always going to be true. So since I ended up with a true statement, it's going to be infinitely many solutions. All right, take a second and do these on your own. I would probably do 1 and 3 by elimination. I would probably do 2 and 4 by substitution. And I'm just going to talk real briefly. 1 and 3, your variables are lined up over each other. 2 and 4, substitution, because one of your variables, y, is already solved for. So take a second, hit pause, see if you have one solution, and tell what it is, or if you have no solution or infinitely many solutions. Number 1 is infinitely many. Number 2 is no solution. Number 3, you just have one solution. It's 2, 1. And on number 4, it's no solution. So let's do our word problem. The perimeter of a trapezoidal piece of land, that's that first one, is 48 kilometers. The perimeter of the rectangular piece is 144. We want to write and solve a system of linear equations to find the value of x and y. Well, so we've got a shape up here of a trapezoid with an x and a y, and they tell us the perimeter. And remind yourself, perimeter is the distance around. Same thing with the rectangle, the distance around is 144. So my plan is I'm going to write 2 equations and then have a system of equations to solve. So let's go ahead and solve it. So for my first equation, 2x plus 4x plus 6y plus 6y is equal to 48. When you combine your like terms, you get 6x plus 12y equals 48. Do the same thing with the other rectangle. 9x plus 9x, my two sides, plus 18y plus 18y. Combine your like terms, and you get 18x plus 36y equals 144. Well, what I need to do is create opposite coefficients. Well, we're going to do it by both methods. Graphing, I don't think is one that I would really stick with too much, but I'm going to show it to you really briefly. It's going to be one line on top of the other. I would have gone with elimination on this one, where you create the opposite coefficients. So multiply that top equation by -3. And what happens is everything cancels out. So you get 0 equals 0. Either way, you're going to find out that you have infinitely many solutions, because the lines lie on top of each other. If you graphed it, you get a true statement of 0 equals 0 if you solve it by elimination. So that really means that x and y could be any number, and they are saying it has to be in that first quadrant, and that's because perimeter has to be positive. You can't have a negative dimension. All right, that's all I have for this one. Hope you enjoyed.